Okay, let's get into it. Today, we're doing a deep dive into something that's a massive variable for any agricultural producer, rain risk.
Hmm.
Our mission is to really unpack how financial tools, specifically these things called precipitation options, are priced, and maybe more importantly, how well they actually work for farmers.
And it's a fascinating area because we're talking about weather derivatives. These are financial instruments, futures options that are based on something like rainfall.
Right.
And they neatly solve two of the biggest headaches you get with traditional insurance:
This would be.
moral hazard and adverse selection. With normal insurance, a farmer might, be less careful because they're covered. That's moral hazard.
Okay, yeah.
Or maybe only the highest risk farms decide to buy it in the first place. But a weather derivative, it pays out based on an independent number, like rainfall at a specific weather station.
So the farmer's actions have absolutely no impact on the payout.
Exactly. It's a very clean instrument for managing pure weather risk.
And to make this real, we're looking at a case study of grain producers in Brandenburg, Germany. They are just incredibly vulnerable, sandy soil, not much irrigation.
Yeah, the conditions are tough.
And get this, over a 20-year period, the rainfall they depend on in April and May, it swung from a bone-dry 4.5 millimeters to a flooded 136.3.
That is an unbelievable amount of volatility. To manage that, you need really accurate pricing models for the options they might buy. Say a put option if it doesn't rain enough, or a call option if it rains too much during the harvest.
So the research breaks down 3 ways to price these. The first is the simple one, right? The burn analysis.
Right, that's just the benchmark. It's a historical simulation. You're basically just looking at past rainfall data directly to figure out the odds.
And the second?
That's the index value simulation. It's a bit more sophisticated. It tries to fit the historical data to a smooth mathematical distribution.
Forcing it into a pattern, in a way.
Sort of, yes. And then there's the third approach, the most complex one, the daily simulation.
And this one is different. It's not just looking at the monthly total.
No, it builds the month day by day. It accounts for things like seasonality, heavier rain in the summer, and even autocorrelation.
Autocorrelation being the idea that a rainy day makes another rainy day more likely.
Precisely. But this is where they found something really critical. Even though this daily model is super detailed, it tended to underestimate total monthly volatility.
Wait, hold on. The most detailed model misses the big picture. How?
They called it a low-frequency variability bias. Essentially, the model is so good at capturing the day-to-day noise, the small changes, that it smooths out the massive long-term swings in the monthly total.
The very thing the option is based on.
The exact thing.
Wow. And because option prices are so sensitive to volatility, a lower estimate means what? A cheaper option.
A cheaper option, yeah. But one that might be misleading you about the true cost of your risk.
That's a huge modeling issue.
It is, but honestly, it's not even the biggest practical problem that farmers face here. That would be basis risk.
It's basis risk. This is the real Achilles heel for these things, isn't it? It's the mismatch between the weather at the official station and what's happening in your actual field.
And for rain, which can be so localized, it's raining on one side of the street but not the other, this risk is just catastrophic.
And the research actually quantifies this drop-off.
It does. The correlation between the weather station and a farm just plummets with distance.
We were talking about it going from, about 0.9 if you're 25 kilometers away?
Which is still pretty close.
Down to only 0.5 when you get out to 200 kilometers.
And the financial impact of that is massive. I mean, think about it. If your farm is right next door to the station, 0 kilometers away, you could use a put option to cut your profit variance by about 65%.
A huge reduction in risk.
A huge reduction. But if you move just 900 kilometers out, that derivative is no longer tracking your reality, and your risk remains incredibly high.
So the core takeaway for you, the listener, is that these rainfall derivatives are so much more regionally confined than something like a temperature derivative.
Temperature is much more widespread.
For rain, it seems like the whole thing really only works if you're very, very close to that official measuring point.
Which leads to a final sort of provocative thought for you to chew on, given that location is so critical and that an index like total monthly rainfall doesn't capture everything.
Right, like whether the rain fell gently over a week or all at once in a damaging flood.
Exactly. So the question is, if you had a truly dense network of weather stations, what specific weather index beyond just the sum would actually do the best job of reducing risk for a farmer? That's really the next frontier.